In the morning session, we were interacting when a Gauss-Seidel technique was used to solve for the load flow analysis for the voltage solution. We came across some factor called as acceleration of convergence of load flow solution. It means because it is being an iterative process, basically on the basis of initial guess of values, means initial assumption, the actual final answer to get it actually within the range prescribed, we call it as a tolerance. It may take several iterations to reach that destination. While processing from the initial estimate, how close is that? How far is from the original answer? We don't know. It is called mere initial guess. From that initial guess, as a successive iterations keep on taking place, plus one iteration, plus one iteration, plus one iteration, like that, till the convergence criteria is met, number of iterations are consumed. By this way, the process of convergence make itself far away and take a lot of time. In that regard, an acceleration of convergence characteristic was viewed by experts. What they used to do from the initial estimate, let us take iteration number 1. Once you have taken iteration number 1, you might have got all the variables revised. That's called estimate of old variable. At the end of iteration 1 is they are revised values. Before using them in the next iteration number 2 for your acceptive criteria to be fulfilled, don't use directly those values. Accelerate them, tamper or modify them such that the next solution comes very faster to your approach. In that regard, acceleration of convergence was one technique preferred for a voltage solution. You can see to that for any voltage of a bus number I, for any iteration, say R plus 1 iteration, R may be 0, R may be 1. Here, currently, if I am running Rth iteration, say iteration number 100. And 101th iteration, if I want to perform, I will be having 100th iteration values readily with me. What is the value I should substitute to get 101th iteration output? For that, we say value of voltage VI. Ith bus voltage at 101th iteration is value of voltage of that ith bus at 100th iteration, VIR, plus the acceleration factor alpha to be multiplied to a difference, that's called the delta V. That's the difference of what? The current value and the previous value, the mismatch, what we call as a mismatch or a displacement, which is the delta V. Delta V, rather than adding that delta V to the previous estimate to get the best value of VIR plus 1, we multiply it by an alpha, which makes this mismatch to raise faster to get the VIR plus 1 better. In that way, this concept, suppose if alpha goes 0, just imagine, alpha goes 0, it directly the value of VIR plus 1 is equal to VIR itself, because alpha on multiplication with the delta V goes 0. There is no acceleration concept originally. That would make what you got VI of R is the one we have to substitute in the next iteration. Instead of that, rather than substituting VI of R directly, make some displacement with the delta V with alpha operated on that, which will definitely make a progress in the solution of VIR plus 1 in a better way. In that regard, research has been carried out by various power system engineers and those people working in power sector. They could find a factor like acceleration of this differential value to the old value. If we adopt, the converging characteristics of the solution of this voltage variable becomes superior and a very timely solution. Within a time, it is able to converge you. In that way, an alpha has been derived as an acceleration factor. Normal range is 1.4 to 1.6. From the literature, you will find it. So this is just to make the solution faster and quicker. If we don't use alpha, absolutely Gauss-Seidel algorithm will run for a solution of load flow, but the time taken for it to converge will be more than the one which we use with the acceleration of convergence factor. This is what in the morning we have discussed. Later we just discussed in case of algorithm for Gauss-Seidel method, in which whenever we come across a generator bus, solution of voltage for that bus should not go directly. It should be taken first as the reactive power ability of the particular generator has to be tested for its Q min, Q max violation. If the generator can keep its injection of reactive power within the range specified, which is called as a computed reactive power ability of a generator, falls within the constraint, then that generator is considered as good, which can be considered as a generator in the numerical solution. If at all the Q value computed for that generator goes out of bound, Q max outside and Q min below, then that generator cannot be remaining as a generator in the process. In fact, it is a load. We call it as a bus switching. That was a test that has to be tested first. Then we have to calculate voltage of that particular generator bus and subsequent process. For that, the complex power at any bus I, Si, from the particular Si, the second term, we call it as a reactive term. The first is active power, second is reactive power. Reactive power term has to be taken, which is called as negative of the imaginary part of Si, which is Vi conjugate and current. Si is called Vi conjugate. Si conjugate, when I take it, becomes conjugate of the work total. It becomes V conjugate and I straight. This term, if I expand, we are going to have this term expanded as any reactive power injection ability of a generator at any iteration R plus 1 is the imaginary part of the product and sum of this entire term, which is split as two terms. One is the ith generator or ith bus which you are working, till that is I minus 1, k equal to 1 to I minus 1, we will be having already solved voltage equation. And I plus 1 and all yet to be solved. In that way, the length of that product and sum is split as two terms. The bus which I am handling is say I, till the ith bus. I was giving in the example in the morning. If at all I was having the 10th bus is a generator bus. All the 9 bus voltages I have already obtained. 10th I am persisting. It means 9 voltages are very much updated, which are called as 9 voltages of R plus 1 iteration I have. And the generator's voltage, if I calculate, that also become revised. That is the meaning. Ith voltage I want to calculate, whose Q is my need. Hence, I am calculating Q of a generator to calculate V of that generator bus. So, therefore, till that I minus 1 minus, I have all the voltages very much updated. We call it as VIR, initial estimate of the bus which I am expecting, conjugate summation of k1 to I minus 1, the elemental data yik from the y bus into vk of r plus 1. What this k refers to? K refers to a bus like I is the bus which I am handling right now. K is similarly a bus which is having the range 1 to I minus 1. It is not going to cross I because till suppose the 10th bus I am working, till the 9th bus I have a solution. That is called as K is I minus 1. So I is 10, I minus 1 is 9. Like that, the 9th voltage is readily available, which is updated, which was not in the Gauss method, which is in the Gauss signal only. Then after the 10th bus, we can see here, same term in the next block, K equal to 10 and later to the last N, which is having YIK, VK of R. What is VK of R? Old solution, initial estimate. VK R plus 1 refers to latest evaluated value. VK of R refers to the one which is just obtained in the previous iteration. So in this way, this equation is utilizing the power of Gauss-Seidel approach, wherein the reactive power computation must take place using this equation, and that has to be checked with limits of which then we have to say whether that particular bus is going to remain as a generator or going to switch itself as a load bus. Accordingly, the treatment has to happen. In that way, we have seen similarly what is delta of a particular bus. It is called as angle of a voltage vector. We have to assume. So this was what we have seen in the morning class. Then later we took a load flow flowchart. Now I have revised the flowchart. This is another file which I was carrying in the morning. I could not show it. So flowchart for GSLF. How to start the process? You required collection of data. You require to form all the data in the form of number of buses, how many generators are there, how many loads are there, how many elements are there, which is the slack bus number, where all you have compensating devices, what are all the P and V values of a generator, what are the Q limits of a generator, then what are the loads at respective buses, P, Q, etc. And what is the maximum number of iteration you are permitting, what is the tolerance factor of this acceptance of this solution, what is the acceleration factor if you are having. They are called as preliminary data, which is put in a rectangle box. You can see there, all these rectangle data information is called pre-processing data, which is required to run an algorithm under GSLF. Like that, we require for NRLF, Newton Raphson, fast decoupled, like that. We call it as data set required for load flow. So you may be having a question. What are the important data set required for the load flow study? You have to write an answer. Data set required for the load flow study are as follows or likely. System size, number of buses in the system should be known to me because that limits my Y bus dimension. Number of buses in the system, which give me how many terminals are there in your system. Number of generators, how many generators are there, where all they are positioned, I must know. How many loads are there? They are called as the load buses. I must know that information because I have to change my logic. Whenever I process generator data, generator based calculation I should adopt. Whenever I process load data, load dependent things I should work. Like that, where all we have voltage controlled compensating buses, where it is located, what is the capacity of that, how much max and min capacity it can compensate. Like that I should know. Then I must know the first and foremost slack bus, which is the number in this system which is called as a reference bus for you. What are its values of V and delta? So all these things are known. Then number of transmission lines in the system is also required. That's called the geographically spread power system. What we have, how many transmission lines are there, how they are interconnected, what is the elemental admittance of that, how you frame that into Y bus. So all these things are primitive parts. Next comes how many iterations you are permitting for it to execute. How many, what are all the tolerances which you permit it to run. So all these things you need to collect as a primitive information. This is worth 5 to 6 marks question. What are the data set required for the load flow study? It was one best question for your old scheme of your seniors, 15. It must be one of the objective of your study as well. So that is put in the rectangle box number 1. Once it is readily collected, whichever the method I adopt, so this data set is very necessary for me to conduct load flow study. Once I conduct, my next step is to for Y bus using relevant rules. So I have to configure system physical interconnections into mathematical form of its representation as Y bus. So system admittance bus need to be formed. Once I form a system admittance bus, which is readily used in calculation of bus voltages. So next, make all the initial assumptions. As I was speaking about, the Gauss-Seidel technique use successive iterations or successive approximation and update of values. So here my variables are voltage and angles. So to get the voltage solutions of all the buses except the slack bus and angles of all those voltage vectors, I should start initially, some reference must be taken for them. Then mathematically I should keep iterating with the use of equation and check for the correctness of the equation comparing to previous and the present one, which is correct, which is updated, which is to be rejected. Like that, to do that, I should have initial estimate or initial assumption. Usually 1 angle 0 or 1 plus j0 is referred. That's called as flat start, where voltage is taken as a magnitude 1 and deltas are considered as 0. If you have load buses, generally this is very suitable technique. If you have generator buses where you have V and angles are mentioned, V is mentioned, the angle P, V is given, capacity is given, V is given. So it is better to assume the same voltage which is given in the problem for generators. Then it becomes one step advanced for your solution. If at all nothing is pronounced in the problem, only the keyword use flat start is mentioned. Then flat start should suggest all the voltages and angle should be considered as one angle 0. One stand magnitude of the voltages, 0 stand as the angles of that particular voltage. In that way, flat start must be the 1. You can see there, all the voltages must be considered except slack bus. Hence, the make initial assumption Vi is 0. The power is 0 means all initial conditions from I equal to 2 to M means 2 means leave the bus number 1. He has considered bus number 1 as reference bus like that. So next, once it is considered, you start computing the values of the calculation of Vi and all the constants. So this block is also extra because this is referred in the Kotari textbook. He is mentioning compute AI, compute BIK. What are AI, BI? These are the equations. Vk equal to 1 by Ykk in the bracket Pk minus Jqk over Vk conjugate minus summation K1 to M, and you have Ykm and Em, whatever the equation not equal to S. We have written it. In that regard, the equations with the constant appear like P minus Jq by Yii. They remain constant. P is also constant, Q is also constant, Yii is a constant. Those constants were substituted by AI and BIK in the book. So you do not worry about this. If you can skip this step, nothing wrong, because when you use the respect to voltage equation definitely consider these two. So it means to say, so I should be in a position to calculate voltages of all the buses, and I should make my steps very clear. Once I come down, set the iteration count R to initial condition, say 0. The author is beginning from 0 and he is going +1, +1, etc. And he set the iteration count to 0 and he starts. If it is a PQ bus, see here, there is a change here. In the modern session, what I was shown a flowchart from the old textbook, is the bus is PQ bus or a PV bus. There was a decision box. Nothing wrong here if we insert one more decision taking block. If the bus is PV, go down. PQ, go branching. Like that it was done. But here, author presumes that if the bus is PQ bus, what should be done? Take bus count equal to 2 to and continue and assume delta mismatch of voltage be 0 and start computing Vi of R plus 1. What is this Vi of R plus 1? It is the Vk equation which you have seen in the morning class. Vk is equal to, like I pronounce it, Vk of R plus 1 equal to 1 divided by Ykk in the bracket Pk minus Jqk over Vk R conjugate. There comes R, not the R plus 1, R conjugate minus the summation block. So it means I should process the voltage from that particular bus. This is because of PQ bus. Then I should Am I audible? I think many of you are left the meet, so I'll be expecting you back. Okay, get back to the meet. The data mentioned here, hope you are able to see my sketch. Yes, you are able to see, visible here. A small problem I am taken. How to apply this Gauss-Seidel solution to numerical approach, we will see. And this is the problem I have picked. The problem is having 4 buses. The transmission line data is given in the form of what is this R and G. Let me write here. Then let us see how exactly this problem works out. So line 1 to 2, this is admittance, it is 2 minus J6, I write it as a per unit line, and line I have 1 to 3, it is 1 minus J3, then I have 2 3, which is 0.666 minus J2, then I have 2 to 4 as 1 minus J3, then I have 3 to 4. 3 to 4 is 2 minus J6. So this is the data given. The table is having this information. The information over here is the elemental representation between the bus 1 and 2, 2 and 3, 3 and 4, etc. as admittance is given as admittance. Hence you are able to see line and you are able to see admittance in per unit. Then we will see how remaining data is given. The remaining data which is given over here is like this. I put it one block. I put it as a block like this. Okay. Now next data given is the power. What is the bus number 1? What is bus 2? What is bus 3? What is bus 4? I should give you information about the buses. For that I have like this bus, then I have PI in per unit, QI per unit, VI per unit, and remark. So what is this exactly? I have information given here. How many buses are here? By count there are 4. Then I should write bus number 1, 2, 3, 4 and its indication. What is bus number 1? 1 is given as P is not mentioned, Q is not mentioned, then it is given as 1.04 and angle 0. This is called as slack bus or reference bus. Then I have bus number 2, bus number 3, bus number 4. I have to check whether it is visible to you. Yes, all the 4 are visible. Yes, fine. What is bus number 2? Bus number 2 is here, this bus. Bus number 2 is given P specified as 0.5. 0.5 pu. This is minus 0.2 pu. Then voltage is not given. It's called as PQ bus. Load. What is the load? Power at bus 2 is 0.5 pu active, 0.2 pu reactive. That's the meaning. What is the bus 3? Bus 3 is also given as PQ bus. No doubt. The values mentioned here is minus 1.0. Then it is 0.5. Then it is voltage is not given. You have to calculate. This is also PQ bus. And bus number 4, last one. Hope it is visible. Yes, it is visible. Bus number 4 is having the generation data or load 0.3 pu and this is minus 0.1 pu. Voltage is not given. Then it is also given as PQ bus. So you have been given the information like this. If you want, I can put a rectangle block for this also. I will make a block here. I will rewrite it. How do I do it? Just I put block here like this, which makes a complete remark. VI, PU, remark like this, like this, like this. I will get a table of information. The first table refers to transmission grid. The second table refers to type of bus and whatever the information given to you. Then what is obtained? Question. Obtain voltage and angle of all the buses at the end of first iteration. Use GSLF method. You can read this. What is this? Obtain voltage and angles of all the buses at the end of iteration number 1 using Gauss-Seidel load flow technique. So you need to begin with this. You have been given 4 buses, 1, 2, 3, 4. You have bus information. You should see very carefully. Bus number 1 is given as voltage of 1.040 pu, which is said as reference bus. How about other buses? All are load. There is no mark here. We will not worry about that. Whether it is indicated as generator bus or load bus is of our interest. It means PQ, nothing but bus. P and Q are mentioned. What is unknown there? V is unknown. Delta or angle is unknown. That is my task. Obtain voltage and angles of all the buses at the end of first iteration. Use GSLF method. Now, do I need to calculate any voltage of slack bus? Definitely no, because slack bus is mentioned with a voltage 1.04 angle 0 pu, which is a reference bus, which must be here. I have to calculate V2 delta 2, V3 delta 3, V4 delta 4. This means V2 delta 2, V3 delta 3, V4, delta 4 are your question. You have to calculate all these 4 quantities. So it means 6 quantities. V2 delta 2, V3 delta 3, V4 delta 4 pertaining to bus 2, bus 3, bus 4. So therefore, how to work it out? Now we should check. It is a load bus, load bus, load bus. So recall back. For the solution of voltage equations for GSLF method for the load bus, we had an equation V. So let me write here. How to write that equation? Let me write one and I will make you comfortable. So equation what we have to refer over there, standard equation, let me put one. So you will be able to get this equation. We know that for any bus I, how to calculate the voltage? We know. So we have VI R plus 1 equal to voltage of bus number I. Any bus I now have 1, 2, 3, 4, except that is only 3 possibility. It may be 2, it may be 3, it may be 4. So like that, VI R plus 1 equal to, we have the solution 1 by YII. In the yesterday's equation, we have seen KK like that. So now I'll be using PI minus JQI divided by VI R conjugate. I write it this way. Okay. Conjugate minus summation K equal to 1 to I minus 1 YIK VK R plus 1 minus summation K equal to I plus 1 to N. N means last number for me in the system. I will be using the same equation YIK VK of R. This is the bracket complete. This equation I have to use. What does exact indicate? Bus of I, voltage solution at any equation R plus 1. Suppose you assume R equal to 0. Let's assume R equal to 0. What will happen? V2. Let me write here if you want. For bus 2, how it will work it out? It is V2 of 1. Voltage solution of bus 2 at the end of iteration 1. R equal to 0, 0 plus 1 is 1. V2 of 1 is equal to, how you write here? 1 divided by I. Y 2. Let me write it here. Okay. What is I? It is P2 minus, what is QI? J Q2. This divided by, what is VI for you? I is 2. What is R? Previous to this. So let me write here V2 0. Can you see here? Now this became 0 plus 1, 1. What must be this? V0 conjugate. V0 conjugate. Means initial estimate of expected variable V2. It is V0 conjugate. Minus. What is this? This side expression show you the connectivity. Which bus you are working? Bus 2. From this, where all you have connection, you should check. So possibility of K is 1, 2, 3, etc. till what? Less than I minus 1 with the voltage solution updated. And this one, of course, I am working first time. I am leaving 2. I don't have solution of 3, solution of 4 here. Then question comes here. What are the values I should use? Let me write here. So this becomes Y. Let me look into this. Y 21 V1 minus Y23 V3 0 minus Y24 V4 0. I stop here and a moment and tell you what I did exactly here. What is this? 2-1. What is this? 2-3. What is this? 2-4. How I could write directly? This is the expression. The link K tending less than I. I is 2 for me. K can have only one possibility, which the value of voltage is latest available. I do
Sir,
not. Please, please.
sir, video is blurred, sir.
Video is blurred, and then I'll close the session. That is the only good thing I can do, because we cannot do beyond this point. Because it's almost for me very clear here. I'll check in my mobile if it is so. Because this kind of things will work only on board correctly. I would have taken so much of classes, and the pain is very, very dangerous for us. I'll try here on my mobile. If it comes, I'll continue. If it goes back, I'll close the session. That is the only thing, good thing I can do. I'll try it in my mobile, okay? Because these direct one-to-one classes only will run good. Distance classes will have a lot of problems. I'm trying here, just a minute. Because of internet connectivity also it matters here. Maybe that may be the problem. I'll try here, okay? In my vision, how is this? I'll just check. Okay, 1 minute, I'll check here. When I too find blur here, you are correct. I too find blur here. I will try once, just refresh. I will try once and I will do it, okay? Once I will refresh here, I will try. I think now it has come back. Hello? Someone in the class can communicate to me. Now it is clear, I think. In my mobile, I am able to see this.
Yes, sir, now it's clear.
Okay, I'll go back. No problem. Maybe network issues might cause this. Okay, no problem. If it is possible, I'll correct it. If not possible, I have to discourage myself. Okay, I'll come back to the board. Okay. Now, where I was, this equation V2 of R plus 1, nothing but solution of voltage of bus number 2 at the end of equation number 1 is V21 equal to 1 by 2. Wherever there is a I substitute 2. Wherever there is a R plus 1, I keep substituting the equation. Then I'll be having this equation P2 minus JQ2 over V2 R is 0, V2 0 conjugate minus this term. These terms directly I will write, because I know that from bus where all connectivity exists, there is a connectivity between bus 2 to 1, bus 2 to 3, bus 2 to 4. How many I have? 3 elements. Are there 3 elements here? 1, 2, 3. I will tell you the trick how to do it. Just look at the diagram. Bus number 2 voltage you are trying to solve. 2 to 1 is a connection. Yes. Y21 is the element. Y21. Can you see here? Y21 into voltage of the bus where it lands. 2 to 1 you are connecting, where the second subscript 2, 1, whose voltage? Y, your bus 2, where is connected? Bus number 1, Y21, V1. What is V1 for you? Flat bus voltage, and there is no 1, there is no 0, there is no conjugate formula. It is called as reference bus voltage, which will not change. Hence, Y21, V1. What is the second term? Because this is minus will continue. Minus, you can see here, 2 to 3 I have a line. It must be transmission line. Y23 I wrote here. Y23. Y23 means 2 I have begun. 3 is my destination. Voltage must be V3 0. Why it is V3 0? V3 is also one of the unknown like V2 for me. Still it is not checked. Still it is not worked out. Hence it is V3 0 means initial voltage. Initial voltage V0. Similarly, I have one more line between bus 2 and 4. 2 to 4. Then I will have minus Y2, which is the bus which I am referring. 4 is the one where it gets landed upon. Whose voltage? V4. Again V4 0. What is V4 for you? V4 is one of the unknown. V2, V3, V4 are your one of the unknown respectively. Hence, still it is not checked. I am at bus number 2, whose first iteration value I am trying to work out. Bus 3, I have not done. Bus 4, I have not done. Hence, these remain as 0, 0. It means these two terms have come from this group. Here, they have come from this group. You can see here. So what is I? 2. 2, 3 means this block from here. This block from here, 2 terms. This is from here. K is 1 to I minus 1. What is I here? I is 2. Minus 1 means only 1. So from here, this term has come. So I will not worry about this. If I fall systematically with respect to expression, I will be looping around. Rather than that, look at the connectivity and check the connectivity. From 2, there is a connection with 1. One term will come here with the V1 and Y21. And 2 to 3, there is a connectivity. Y23, V3 will come here. V3 is because yes, I am in 2, 3 must be 0 initially. That is not catched. Similarly, 2 to 4, another connectivity is there, Y24, and whose voltage is 4, V4, 0, initial voltage not yet checked. This way, this is the voltage equation I should solve. Then these are the values I have to substitute. Why I am taking this? Now look into this. Do you have Y22 with you? You do not have. Where is Y22 present? Y22 is nothing but if I draw roughly over here, what is Y bus? Y bus of a system is a pack of matrix elements like this. I have to write the element 1, 2, 3, 4 like this way. Correct? I have to write the element. This element is from Y bus. Let me write here. From Y bus. I have to fetch this. I must know system admittance bus. For this problem, from this first table, I have to obtain Y bus, whose Y bus, one of the elements Y22 is useful to me. To solve this, I require Y22. Y22 is available in Y bus. To get Y bus, I have to use this table. This is the reverse link. So I am giving you where do I get this Y22. Next, what is this P2, Q2, etc.? It is called the power active situation at bus 2, power reactive situation at bus 2. Where these two are available? Look at the lower table. The table in the below, which is showing you bus 1, 2, 3, 4. Go to P2 means bus 2. At bus 2, row number 2, you just go. What is PI given here? 0.5. PI is nothing but active power situation. Directly he has given PI. He has not given P generation, P demand like that. Directly he has given demand at bus 2. That's all. Therefore, this is a direct drag and drop. This 0.5 has to come and assemble here. This P2 is from this table. What is Q2 for you? Q2 is minus 0.2. Place the Q2 position here, minus 0.2 here. Just all. So drag and drop from this table. Row number 2, which is a PQ bus, P2, Q2 you have to fetch and place here. It's clear. Now question comes, I'll move, before this I'll move this. What is Y21? What is Y23? What is Y24? They are the like Y22 elements of Y bus. I must be performing Y bus before doing this. Therefore, I have given you an expression. This expression demand you. This expression I took because just now we took discussion on load flow chart. Hence, where this is useful, what are all the mathematical requirements for that, I am trying to connect and will solve it in systematic way. So, Y22, Y21, Y23, Y24 are the second row element. Third row for third bus, fourth row for fourth bus. First row I don't want because it is stack bus related. I will not be doing it. That's a reference bus. Therefore, this Y bus frame 4 cross 4 Y bus I must obtain. From them I will be filling these Y22, Y21, Y23, Y24. I mentioned where do I get these? Where do I get? What is left in this? V20, V1, V30, V40 are left unaddressed. Let us say one by one. We will check first V1. What is V1? What is V1? V1 is the voltage mentioned at bus number 1. What is bus number 1 for you? Look at the bus number 1. What is mentioned here? No power I. Pi is not given. Qi is not given. But Vi is given. I is 1. V1 is 1.04 angle 0, which is called as slack bus, reference bus. Therefore, V1 is default given from slack bus. Okay, slack bus. So this is given here. How about others? V20, V30, V40. They are not known. They are called as 0 at the superscript. 0, 0 like that. They are called as initial estimate, initial guess of a variable. Now I ask you a question. What are variables? The unknowns in this system are called as variables. Voltages are my unknown. Angles are my unknown. Therefore, I am solving voltages. Then voltage must be unknown to me. They are the variables. Then how many unknowns I have? V2, V3, V4. Delta 2, delta 3, delta 4 are my physical unknown. I should calculate over here. Then to calculate V2, I should have initial estimate of V2. To calculate V3, I should have initial guess of V3. To calculate V4, I should have guess of initial V4. For the iterative process, what I am trying to apply using Gauss-Seidel, I require V2 of 1 at the end of iteration 1, which require initial guess of V2, which is called as V20. When I have V20, likewise, V3 is also connected in this problem. V30 is required. V4 is also connected by transmission line. V4 is also required. Hence, I should say, this problem requires one instruction. What is the instruction? Whether these voltages are given to you or said to calculate. Of course, in this, they are said to calculate. Then, which is your reference point? How do you begin it? I said in the discussion in the flow chart, usually the method called as flat start. Let me clearly. Flat start is chosen. What do you mean by flat start? The flat start means the variables are given 1 angle 0. 1 angle 0 as their solution. 1 angle 0 as their initial estimate. I would otherwise say 1 angle 0, 1 angle 0, 1 angle 0, or in a complex rectangular 1 plus j0, 1 minus j0 you would have written. They are called as initial. When you use a flat start, voltages must be assumed. Slack bus voltage you should not assume because slack bus voltage will be given to you. If there is a generator bus, by chance, this problem is not having generators other than slack bus. If there was something generator bus here, voltage must be given. Voltage must be given, whose Q will not be given. PV, P must be given, Q must be given. In that way, we should check the data carefully. So I am trying to address you for a V2 calculation at the end of iteration 1. This is the expression. From this equation, I can generate, or directly from the connectivity, I can write it. If anybody would like to know how to get Y bus, nothing wrong. Use Y bus by instruction method. How many buses are here? 1, 2, 3, 4. Physically 4. What must be the dimension of Y bus here? 4 cross 4. So orally, by instruction method, I must be able to get Y bus by instruction method. I'll be able to get Y11, 12, 13, 14, 21, 22, 23, 24, so-called 41, 42, 43, 44. All the 16 elements I must be able to present in the matrix form. That is called as a Y bus for me. Once Y bus is ready with me, initial flat start concept is understood by me, I am in a position to solve this problem. Hope I made the start carefully and you understood the table of information given to you, and you are able to get now the representation of this data into meaningful calculation. Now what I will do, I will be repeating these equations without fail on the board. Before repeating, let me make y bus of this table first on the board. Let us obtain y bus, remove the y bus. Let us take V2, V3, V4 equation. Let us present them in the data and try to calculate. We shall do this in systematic way. Because it's the first problem, I am going very slow in particularly whatever the steps, term keys are there, I am trying to mention. Once you are familiar, no matter, it will take a click of time for you to do with the calculator. Okay. Now, this is the gist of the problem. That is V2 you did, V3, V4 I should do. That's all. When V2 I got by numerical value, put in polar form. V2 delta 2, V3 delta 3, V4 delta. That's the end of my problem which is given to me. So this way you need to be careful. So now my next task is to obtain y bus. So I retain these two, remaining I eliminate, so that y bus can be explained and obtained by you all using first principle of inspection method. I write it on the board. So when I show you the problems on the PPT, you will be able to grab it faster if you do at least once. So y bus by inspection method. Now may I know, anybody remember how to form y bus by inspection method for this problem? I have been given 1 to 2, 1 to 3. What is y11 here? Y11 is the sum of the admittances of the line from 1 to remaining buses. From this table, 1, 1. There is a one number bus here. 1 to 2, there is one line. 1 to 3, there is a line. Add these two, place them as a 1, 1. If I write here y bus like this, I'll present here. Okay, 1, 2, 3, 4. What is y1 cross 1 for me? Sum of the admittances of the transmission line connected from bus 1 to remaining line. How many are there? 1 to 2, 1 to 3. That's all. Add these two. If I add these two, 2 minus J6, 1 minus J6 with J3, 3 minus J9. It becomes 3 minus J9. Hope you are able to get this point. 1, 2, 1, 3. If I add them, that becomes diagonal element first. What is 1 cross 2 here? 2. Likewise, 1, 2, 3, 4. Let me put this bracket here. Okay. Now, what is 1 cross 2? 1 to 2. Somebody was asking me in the chat box, why of diagonals of a particular y bus are negative with the data? It's very clear. When I apply nodal analysis between these two buses, current flowing from 1 to 2 is V1 minus V2 into elemental admittance Y12. When I separate them, V1, V2, V3, hierarchically, the second bus becomes negative with the value. Therefore, when I take that V2 outside, Y12 remain as a negative of the admittance of the connected line. Hence, off diagonals are negative of the elemental representation. Therefore, what is the elemental value of 1 to 2? 1, 2, what is the value? 1, 2. 2 minus J6. Whose negative I should take? It becomes minus 2 plus J6. Okay. Now you got Y1 to 2 is nothing but off diagonal. Diagonals means which fall on the main diagonal. 1, 1, 2, 2, 3, 3, 4, 4. Other than this, which fall on the upper triangle and lower triangle of the matrix are called as off diagonals. Off diagonals are by number. Row number, column number. 1, 2, Y12. 1, 3, Y13. 2, 3, Y23. Like that, I have to announce them. When I announce that number, the elemental data between those two buses should be put with negative, because when I solve by nodal analysis, negative terms come out because the voltage from which the connectivity the connection starts from the particular voltage, I mean bus, and land on a particular bus. When I take current to flow V1 minus V2, the second term is naturally minus V2. That minus will come to the admittance representation for the simplicity of mathematical arrangement. Likewise, is there any line between 1 and 3? Yes, there is a line between 1 and 3. What is the value here? 1, 3. Negative of which becomes minus 1 plus J3. How about 2, 1, 4? Do we have any connection between 1 and 4? No connection, hence it goes 0. So, may I know, all of you got by inspection method, first row pertaining to bus number 1 is filled by viewing the particular transmission system. Y11 is the sum of the admittances positively. Here we will not be taking minus. Somebody may ask me, for the off diagonal you took minus. How about the diagonal? Diagonal is nothing but addition of admittance of the lines connected from the bus you are speaking to the rest of the buses. One I am speaking, 1 to 2. One I am speaking, 1 to 3. 1 to 4, no connection, only 2 lines. Add them. That I did here. When I write off diagonal, 1 to 2, 1 to 3, 1 to 4 so called, then I will have negative of the admittance of the line connecting those two buses must be taken. Hence I have 1 to 2 minus 2 plus J6 and 1 to 3 minus 1 plus J3. 1, 4, no line. I just drop it. Now I was speaking. This line is mirror. I will come here also. I will not worry. I will just pick you. I come to bus 2, second row. What is Y22 directly? Y22. Y22 is the admittance of the lines radiating from bus 2 to rest of the buses. How many lines are here? 2 to 1, 2 to 3, 2 to 4. How many are there? Totally you have 3 physical elements running from the bus number 2. Then I will be taking in this observation, wherever 2 is there, 2, 2, 2. There are 3 locations, 1, 2, 3. Those admittances you keep added up. If I add with this, what I will have? 2 on the real term, 2.66, 2.66, and another one. It becomes 3.666. So I will add this as 3.666. You can see here, there is a 2, 2. There is a 2.66. There is a 2, 1. 2, 2.66 plus 1, 3.66. How about the reactive term? Minus J6, minus J2, minus J8. Again I have minus 3. It becomes minus J11. Minus J11. Can you see what I did here? Sum of the admittance of this line plus this line plus this line is put in 2 cross 2 diagonal. I did it. By instruction I can do it. Now what about 2 to 1? Y21 is negative of the admittance between 2 and 1. Is same as 1 to 2. What is this 1 to 2? This term is copy paste here. So it is same as 2 to 1. What is the line here? Minus 2 minus J6. Negative of this I have to take here. Nothing but copy paste this. So this is minus 2 plus J6. Readily available. How about 2 cross 3? Bus 2 to 3. Is there a line? 2, 3. There is a line here. What is the line 2, 3? 0.666 minus J2. Then negative of this will be appearing here. That is minus 0.666 plus J2 is the line which you find here. Is there a line between 2 and 4? There is a line. That line is 1 and minus J3. It becomes opposite to this. This minus 1 plus J3. You check this. You have a line 2 to 1, 2 to 3, 2 to 4. These data are negative, negative, negative. If they are in the real positive, 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 you add them, it becomes diagonal. You can add this if it is negative of this one. Real time, real time, real time. Add all together, condense them diagonally. It becomes diagonal. And negative, negative, negative means they are called off diagonal elements in the matrix. Likewise, I move to bus number 3. How many elements you have here? 1, 2, 3. 3 to 1. I have 1, 3 is same as 3, 1. 2 to 3, 1 line. 3 to 4. Wherever bus number 3 appears here, 1, 2, 3. 3 times it appears. Add them. Place them on 3 cross 3 as a diagonal element here. So, how much is the value? 1, 1.66, 2. It becomes again 3.66. This becomes 3.666 minus J3 minus J2 minus 5 and another 6. It is minus 11, minus J11. Okay. No matter, it looks similar. Don't worry about that term. It is connected to my problem. This is the problem of 2 cross 2, problem of 3 cross 3. Will not worry. Are they same or not? It is not our problem. Okay. So at bus 3, 1.66 and we have 2. It becomes 3.66 and 3 plus 2, 5, 5 plus 6, 11. So it is minus J11. This is called diagonal value at bus 3. Now I should write bus 3 to 1. Is there any connection? 3 to 1, 1 to 3. Already you have here. What is 1 to 3? This number. You copy and paste here. You copy and paste here. What is this? Minus 1 plus J3. So your work is already done there. Then what is this? Bus 3 to 2, 3, 2. It is done. 2, 3 is ready. 2 to 3 is ready. It must be 3 to 2. So this also I copy paste here. This becomes minus 0.666 plus J2. If you have not got it, how do I get it directly? You go to this. Is there line between 3 and 1? Yes. 3 and 1. 1 minus J3. Minus of this. Is here. Is there line between 3 and 2? Yes. 2, 3 is same as 3, 2. 6, 6, 6 minus J2. Negative of it. It's here. No matter. It will be there in the table. So only the cyclic understanding and presentation of the problem works out for you. Then how about 3, 4? Do you have 3 to 4? Yes, you have. 2 minus J6 and minus of this become minus 2 plus J6. It becomes minus 2 plus J6. So you got all the 4 terms over here. You are left with the 4th bus. Look at this table. How many 4 location is there? Bus number 4. Only 2 locations. 2 to 4, 3 to 4. You can check here. There is a bus between, element between 2 and 4, 3 and 4. Only these two you have to add up and write to the diagonal. What is this value? It is 1 minus 3, 2 minus 6. 3 minus J9. It becomes 3 minus J9 is my diagonal element. Now I would like to ask you, is this bus 4 having connection with the bus number 1? No connection. As you have seen, 1, 4 is 0, 4, 1 must be 0. So I copy paste over here. Clear? You can see this row is put as a column here. You can observe. First row is nothing but first column for me. Then, what is this? 4 to, is there any 2? Yes. 2 to 4, 4 to 2. 1 minus J3. It means it is also readily available. Where this is available? Look into bus number 2, bus number 4. This is there. Minus 1 plus J3. You drag and drop here. Nothing but, you can see 2, 4 minus 1 plus J3 you want here. Minus 1 plus J3. It is there in the second row, 4th column. 2, 4, nothing but 4, 2. You just pick and place here. This will be minus 1 plus J3. How about bus 3 to 4? Do you have any element between 3 and 4? 3 and 4? You have. What is the element? 2 minus J6. It must be there in your third row. Third row, 4th column. What is the value here? Minus 2 plus J6. Can you see here? 3 to 4, 4 to 3. 2 minus J6, negative of it, which is already there. So place here. So this is your Y bus. You did. For this at least you got about 3 marks over here for this problem. Obtaining Y bus by inspection method. But we did it on fast track on board. If you really want, one or two steps you can write here, not more steps exclusively. Just a few steps you can leave on the paper. By this instruction method, Y bus is like this. If you write, it's sufficient. So therefore, Y bus is of 4 cross 4. All the elements are there. What it refers? Y11, Y22, Y33, Y44, Y12, 13, 14. Likewise, each element is having like this. Y11, Y12, Y13, Y14. So-called elemental representation. So-called I have Y41 to Y44. So you can see here. So these are the elemental representation. Physically Y11, 3 minus J9. Y12, minus 2 plus J6. From this position, nothing but this position. Like this, you will be able to pick the element for your calculation of V2 of 1, V3 of 1, V4 of 1, like that. Hope you got the sequence. How that V2 of 1 is obtained? This is a mathematical work one should do before that V2 usage. I presented the V2 because just we completed the flowchart. How it is used to recall you, I did it. Now, this is the actual systematic work. Once you see a problem, first work is Y bus. Once you get Y bus, read the content and you start writing the equations of V2 of 1. Let me write here now. Therefore, V2 of 1 is equal to, let's see. What is V2 of 1? Let me write here. 1 divided by Y22 in the bracket P2 minus JQ2 over V2 0 conjugate minus Y. See here I am writing directly because I have the connectivity 2 to 1. That's why I write Y21. I will not fall to particular equation. Minus 2 to 3 I have. 2, 3. V3, 0 I write here because it is initial voltage. Minus Y24, V4, 0. I convince you that. How many terms are there? 1, 2, 3. You can check here. How many lines are going out of bus 2? 1, 2, 3. 3 terms are here. 1, 2, 3. Why negative? Because these are off diagonal. 2, 1, 2, 3, 2, 4 means what? They are other than 2, 2. Off diagonal. Hence, off diagonal becomes negative in the representation. Now, I will convince you off diagonals are negative because I am referring the values of these Y21, Y23 directly from here. Pick and place. Pick and place. In some of the books, author will not use this capital Y. They use lowercase y. What lowercase y refers? Elemental admittance. The difference between capital and small notations in power system is 1 negative. So we'll see that when I come to a particular book problem, I'll convey you how to refer this problem because author has dealt in the initial stage. What is primitive element? What is Y bus in that explanation? Okay. For me, I am referring CAD L Abiyab and DP Kotari textbook. This is the notation. Capital Y notations are referred. Hence, minus is evident out of which. So now you must know P2 Q2 from this table, Y22 from this table, V2 0. What is V2 0? Initial estimate of variable 2, which is flat part, 1 angle 0. Y21 from this table, 2, 1. This number I'll pick here. V1 I pick from this. Then Y23, 2, 3. This element I pick here. V3 0, initial voltage of V3, 1 angle 0. Y24, 2, 4. And V4 0. You must be very careful. When I work with the bus 2, whole row number 2 is referred. You can see 2, 2 is used here. 2, 1 is used here. 2, 3 is used here. 2, 4 is used here. It means to say, physically you have 4 terms. 1, 2, 3, 4 as of number of terms in the row. That's all. If anyone is 0 there, you should get 1 less. Can you see here? 1, 2, 3, 4. You get 1 less here. When I work for 4th V4, V4, like V2, V4 of 1. This will be 0, 1, 2, 3. You will get only 3 terms there. You are very sure. You will come to know that. Therefore, you must be careful about V2 of 1, how it works out. Now my work is to substitute it. How do I do it? This will be done as 1 divided by, this is a very long expression. One should be doing carefully. 3.666 minus J11 in the bracket. Okay. This is P2 minus J22. What is P2 here? 0.5 minus of minus. It becomes 0.5 minus J0.2. This divided by 1 angle 0 conjugate. This is called as initial estimate of this. So flat start is referred. Flat start is used. Means we will be using 1 angle 0 for unknown. Minus. What is Y21 for you? Minus 2 plus J6 into 1.04 angle 0. See here how I am writing this? This into this in bracket. Next term minus 23. Why 23 is minus 0.666 plus J2 into 1 angle 0 minus the last term 24 minus 1 plus J3 in the bracket 1 angle 0. So hope you are able to see this term represented over here. Okay. It is 1 by Y22 P2 Q2 V2 0 Y21 V1 Y23 V3 Y24 V4. Now if I solve it with the help of calculator, now you must be good in use of calculator. The complex mode of solution you must be able to do. So start working with the calculator very fast. You must be handy with calculation. Once you solve this calculation, you must be able to get V2 of 1 as, let me write the answer today. In the next class, we can just justify. This stand as 1.019 plus J 0.046 per unit. Okay.